Hello guys, welcome back again. Till the last video, after the physical property, one more video I have completed for some important questions. So go through it and check it. These are the questions which comes in the previous exams, NEET and JEE. So according to that, I solved 4 questions there related to the NCRT only. In the next case, we are going to check the reactivity of amines. Lecture number 9, chemical reactivity of amines. In that case, here we are having RNH2, RNHR. These are the amines which we are having, and nitrogen is having lone pair. In each case, nitrogen is having lone pair, children. Here 2 acidic hydrogen present, here 1 hydrogen, and here no hydrogen. In that case, why amines are reactive? So they are reactive due to presence of hydrogen and very important, this point is very important, and lone pair at nitrogen atom. They are reactive due to presence of hydrogen and lone pair at nitrogen atom. What is the specialty of lone pair, children? Two possibilities. If lone pair is present, then a species can work as a nucleophile and it will work as a base. Bases are those who can donate electron donor. Okay, electron donor. So from here, it is going to clear train came, so little bit distraction, sorry. So again, what I am saying, because of the presence of lone pair, amines will work as a base. So we have to check the basic nature of amine. Okay, in that case, basic nature of amine. What is the condition, children? Acid plus base. By that combination, we are able to form salt. So check it once. RNH2, here lone pair, they are reacting with HX because of the electronegativity, partial negative, and hydrogen is partial positive. So lone pair attached with the hydrogen species, and we are getting RNH3, nitrogen is having positive sign, and X is having negative sign. So that is the salt formation. So by this we can say that amines are basic in nature. For aniline, if you want to check, you can check. Same thing, HX minus plus, then anilinium ion. Anilinium ion formed. So by these two reactions we can say amines are basic in nature. Amines are basic in nature. By these two reactions we can say amines are basic in nature. What happened, children, if your salt, whatever salt you prepared, suppose this salt, RNH2 or NH3 plus Cl, not Cl, plus X minus, if it is reacting with water, if it is reacting with not water, base again, then what it will form? OH minus Na plus. In that case, that Na plus NaX come out, one hydrogen with OH, then H2O will come out, and your product again reverse back 1 degree amine. Here you took 1 degree amine, and here again it will form RNH2. Okay. So what is the order of basic nature? What is the strength of basic nature? For that, we will check. Okay. In that case, we are going to check the order. So RNH2, here lone pair reacting with water. So in water we are having H plus, it will form RNH3 plus OH minus. What is the Kb for this, children? Kb means dissociation constant. In the equilibrium it is available, dissociation constant for base. Okay. So what is the Kb for that? Kb is equal to concentration of RNH3 and concentration of OH minus upon concentration of RNH2. Water concentration we have to leave. According to this, Kb is directly proportional to OH minus ion concentration. That means if you are increasing OH minus ion concentration, Kb value increases and pKb value decreases because reverse relation. Many time I told you. And basic nature increases. That is the thing. In that case, we have to discuss the comparison with ammonia, alkyl amine and aryl amine. Alkyl amine comparison with ammonia, and aryl amines comparison with ammonia. Okay, so check it. Alkyl amine versus ammonia. So in this case, this is ammonia, and this is RNH2. So pKb value of ammonia is 4.75, and here 3.22, 4.3.5, 3.5 to 4.2. That is the experimental value. Okay, this is for all 1 degree, 2 degree, 3 degree I am talking. So which is having more pKb value, less basic, so order will be this. Order will be this. Alkyl amines are more basic than ammonia because they are having less pKb value. All the 3 amines, 1 degree, 2 degree, 3 degree, their values lies between 3.5 to 4.2. So this is the experimental thing, and how to understand it and what is the theory behind it. For that we have to discuss different case. Case number 1. Here are NH2. Okay, check it properly. And here are this. In that case, children, this R is showing plus I effect. That means it is pulling electron towards the nitrogen. Here also plus I, 2 plus I, and here also 3 plus I, plus I effect, plus I effect, and plus I effect. What is the work of plus I effect? Pull the electron, pull the electron. You can say these are the group electron releasing group, ERG. They are electron releasing group. So basic nature depends upon the lone pair, children, and if the species is able to donate electron easily, that will be more acidic, that will be more basic. Once again I am repeating, basic nature depends upon the electron donation, and the species which is able to donate electron easily, that species will be more basic. So here already one lone pair is there on the 1 degree amine, and one plus I group is present, and here 2 plus I group is present. From 2 sides electrons are coming on nitrogen, and here from 3 sides electrons are coming on the nitrogen. So who can donate electron more easily? 3 degree, because here electron density will be more. So according to this, order will be 2 degree, then 3 degree, then 1 degree, on the basis of plus I effect. So what we concluded? More plus I effect, then basic nature increases. More plus I effect, then basic nature increases. That you can apply in gas and liquid phase. That you can apply it in gas and liquid phase. So in the gaseous phase, this order you have to follow. That is the case number 1 on the basis of plus I effect. Case number 2, solvation. What is the meaning of solvation, children? Aqueous state, or you can say liquid state. What happened? So we are having ion, that means R NH2 H plus R NH3 plus. In that case, if you are mixing it in water, then what happen? What is the structure? R nitrogen positive sign, from three side hydrogen is attached, that is 1 degree. R R from two side hydrogen is attached, hydrogen positive sign. From three side R is attached, one hydrogen, hydrogen positive sign. In that case, 2 degree and 3 degree. In that case, if water species, the basic nature depends upon the stability of this ion. And thermodynamically, we know that if the species is having less energy, that species is more stable. If it is having less energy, then species is more stable. That we know. According to this, it can attach with water molecule three side. So positive, negative come closer, then they will release energy. So here energy release three times, because three time water molecule attach, and here energy will release two times, and here energy will release one time. So who is releasing more energy, children? This 1 degree. 1 degree amine are releasing more energy. That means here less energy we are having, then here more, then here more. So what is the order now? So the order will be 1 degree, then 2 degree, and then 3 degree, on the basis of solvation energy. 1 degree amine is having less energy because water molecule attach thrice. So 3 time energy released, here 2 time energy release, and here 1 time energy release. So which is having less energy, that species is more stable. So more basic species 1 degree, then 2 degree, and then 3 degree. Next, case number 3, steric hindrance. On the basis of steric hindrance, so here R NH2 R and each nitrogen is having lone pair. So children, tell me according to your opinion, here less steric hindrance, here more, and here very more. So approach to the lone pair is difficult in the case of 3 degree, then 2 degree, then 1 degree. Approach towards the lone pair is easy in the case of 1 degree. So here also order will be this: 1 degree, then 2 degree, and then 3 degree. According to the steric hindrance also same as a solvation, that order we have to follow, because here approach is easy because of less steric hindrance, here more, and here more in the case of 3 degree. So these are the three cases which where you have to pay attention. At the last we will discuss very important question. Many times these questions will be asked. Here RNH2, at the place of R if you are using C2H5, then what is the order of basic strength? So I am writing here C2H5 NH2 C2H5 NH C2H5 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 C2. So what is the condition, children? This is 1 degree, secondary and tertiary. So experimentally it is find that 2 degree, then 3 degree and then 1 degree. That is the order. Okay. But one logic I am giving you, that is not a rule. Again I am telling you it is not a rule, but you can think like that. So in the first case we discussed 3 degree, 2 degree and 1 degree. In the case number 2, 1 degree, 2 degree, 3 degree. In the case number 3, 1 degree, 2 degree, 3 degree. So in all the cases that second degree is coming on the middle. So priority goes to second degree. And then 3 degree is coming, that means this they are following. Plus I effect. This answer based upon the plus I effect. At the place of R, if CH3 is given, then order will be again 2 degree, 1 degree and 3 degree. That is the order. So again this is because of priority, and now 1 degree, then case number 2 or 3 they are following. CH3 NH2 CH3 NH CH3 like this. It is all about the acidic basic nature of amine, children. For aniline one more discussion is pending, that also we will discuss. Aniline versus ammonia. So here we are having our aniline, nitrogen is having lone pair, and here we are having ammonia. So what is the priority? Actually this time ammonia is having more basic. Reason, these electrons are not free this time. Electrons are busy in resonance. Electrons are busy in resonance due to resonance. Lone pair busy. Due to resonance, lone pair electrons are busy in resonance. So that is the order. Because basicity because of lone pair, and lone pair is busy in resonance. That's it, simple. So thank you, children. Please subscribe my channel, forward the video, share the video more. All the very best.